Hello, today we are going to look at some different fuel types. We examined these different fuel types last week, and we're going to do a couple of brief experiments just kind of testing out what it is that we learned. So the first one that we learned about was particle size. And this is literally how big the pieces of fuel are. So in a forest, fine particles or fine fuel would be things like dried needles, very small twigs. And coarse fuels would be things like logs or branches, things that are big and one solid piece. So before I do this though, because I'm going to be burning some stuff in this cup, I want to know the mass of the cup because I don't want to know the mass of the cup in my calculations. I only want to know the mass of the fuels. So we take our cup, and the cup weighs 3.5 grams. So I'm just going to make a note, 3.5 grams. Next thing that I want to do is to measure how much the fuels weigh. And I can do this in a couple different ways, but since this is my fuel here is all in one piece, what I can do is simply measure that fuel source, 0.2 grams. And that's fairly easy to do. So I'm going to move this, and next I'm going to actually burn my fuel source. And we'll see how the fine particles measure up to the coarse particles. So again, this is fine because there's lots of surface area exposed. There's lots available to be burned, very small volume. So light my match. I'm just going to stick this down in here. And it's burning pretty readily. You can see that the fire is going through most of this. Okay. I'm going to let the rest burn off over by the window. Okay, so I've finished burning that. So I want to get the mass of it. Now I have my scale on. I get a mass of 3.6. Now I know that the cup weighs 3.5. So the post-burn weight would be 0.1. And that's because the whole thing, cup plus this, weighed 3.6. So I burned about half of it, and we'll do the calculation on that as well. So that is the fine material. Now let's take a look at coarse material. Coarse material is going to be something like this here. So I've got what is basically standing in for my log, and we're going to see how that burns. Now there's much less surface to volume area here, plus that material can take a lot more heat inside of it before it just starts completely burning. So let's see. Let's weigh this piece out. We've got 5.1 grams. And now let's set it up so that I can put the match down there. And we're going to see what happens when we ignite this. So again, we're thinking about forest fuel or forest fire fuels. And I'll set this down here like I did my other one. And I'll be right back with this. I'm going to take this back over to the window. So we can see with this one that it did char the outside of it, but the match wasn't enough to really ignite it fully. So that would be a good example of in a forest fire, these big chunks don't light up immediately. But if they do get burning, they're gonna keep burning for a long time. Where the coarse material that I had lights up very, very quickly. You can think of a campfire. You start your campfire with small pieces of wood or kindling, and then you throw on larger pieces. So let's see what the mass is now. And now we have 5.0. So 5.0 grams. So we only lost 0.1 gram. We'll talk about that in a moment. Okay, the next fuel type I want to look at is going to be the moist fuel. I'm not going to do all of these, but it just gives you an example of how this might work if you were doing these experiments on your own. So moist fuel versus dry fuel. So you can imagine moist fuel is going to be leaves or grass, things that have fallen on the ground that are still green, maybe freshly fallen, or maybe it just rained and it's rained for like a week and all your materials have a lot of moisture in them. Or they could be dry, and I have examples of dry material here. So let's see what that looks like when we burn these. So I've got my cup. I'm gonna first try the moist fuel. Let's get a measurement of it. That is 0.5. 0.5 grams. And now let's see what happens when we burn it. What I'm going to do is try and prop these up just a little bit so I can put a match kind of underneath this material. And let me get my matches. I'm just going to slide this under, try and slide it underneath. And just what you would expect, it's not really burning very well. I've got it to burn when it was directly in the flame, but then it wouldn't keep burning. So let's see what mass we have left here. Oops, take this off, turn that on. And we have, it's bouncing between 0.4 and 0.5. So we burned a tiny little bit. I'll say the amount we have left is 0.4 grams. Now let's try dry material. So my mass of dry material is 0.3. Yeah, it looks like 0.3 for dry. Now what do you think is going to happen when I light this material? What would you expect to happen? Oops. I'll light this. And also try and get that underneath. And you could already tell that it's going to burn quite a bit better. So I'm actually going to need to move this to the window. All right, I'll be back. Okay, I had to take it over to the window because it was smoking and I'm still inside the classroom. So you could see quite a bit more of it burned, even just with the one match. After I have measured it, it comes out to 0.2 grams. So we'll do some percentage calculations and see there. But that gives you an idea of how some of these fuel properties would either add to a big forest fire or minimize a big forest fire. It just depends on the types of fuels. All right, so now we want to finish up with the calculations in this chart here. So what we can skip a lot of this. This was just a demonstration, so we're not going to worry about burn time. And we don't need to describe our fuels, but I do want to figure out the percent combusted. So pre-burn weight, this is what we started with. Post-burn weight here, amount combusted, so it's just pre minus post, which leaves 1 gram. And then we have to figure out the percent combusted. So I know that 0.1 was combusted. I divide that by my total, which was the pre-burn weight, 0.2. And I get 0.5. Now 0.5 is equal in percentage. Remember, we have to move the decimal over twice to 50%. So I have 50% combusted. If I had gotten like 0.45, that would be equal to 45% combusted because we're moving the decimal twice. So I want you to figure out the rest here. How much was combusted is pre-burn weight minus post-burn weight, and that'll give you the amount combusted. Percentage is amount combusted divided by my pre-burn weight, what I started with. And then, so you're just finishing off this portion right in here. And then you have some questions on the worksheet as well. All right, thank you very much.